Start madla. Okay. So, dear students, in the month of March, we are studied on haloalkanes and haloarenes. But exactly has not remembered how much has completed. So, today we can discuss on the topic organic compounds containing oxygen part 1. We have two parts. So, part 2 we can discuss after the part 1 topic. So, in organic compound containing oxygen part 1 we have to study totally 3 topics: alcohols, phenols and ethers. As we know, alcohols are nothing but they are hydroxy derivatives of hydrocarbon. So, organic compounds containing oxygen. Oxygen part 1 or we can write 1. So, in this we have to study totally 3 subtopics: alcohols, phenols and ethers. Now, let us discuss on alcohols. As we know, OH group is the functional group of alcohol. So, we can define alcohols as these are the hydroxy means OH. Hydroxy means OH. Derivative of hydrocarbons. Derivative of hydrocarbons. So, we can write alcohol in general as ROH. As we know, OH group is the functional group of alcohol. Now, what is this R? R may be, okay, it's a alkyl. Or R may be, or it is alkyl. Alkyl. I will tell you afterwards what is meant by alkyl. Or R may be something it is allyl group. So, R may be alkyl group, R may be alkyl. We know the meaning of arenes. Arenes means aromatic compound. So, to the aromatic ring or to the benzene ring, we have the alkyl group. For example, this is alkyl. When it is called toluene, means arene, alkyl CH3. So, if we substitute one hydrogen atom by OH, now it is called alcohol, called benzyl alcohol. And afterwards, we have a functional group, that is OH, attached to the benzene ring. Remember, this is not alcohol. So, alcohol means the OH must attach to the aliphatic carbon, not to the aromatic carbon. These are called, okay, phenols. If it is attached to aliphatic, then it is called alcohol. Afterwards, allylic group. We know this is called allylic group. CH2 double bond CH, CH2. So, this is allylic group. Here also, the OH group attached to the CH2 group. That is, it's aliphatic carbon. So, these are called alcohols. Now, it is about the classification of alcohols. We can classify alcohols into different categories. It is based on the number of OH group present in a molecule of alcohol. Suppose if you have only one OH group in alcohol, alcohol. For example, CH3, CH2OH. We have one OH group. It is called monohydric alcohol. Hydric means here OH. Mono means one. Then dihydric alcohol. If there are two OH group, then it is called dihydric alcohol. If we have three OH group, then it is called trihydric alcohol. And if it is greater than 3 OH group, then it is called polyhydric alcohol. So it is ethyl alcohol, one OH group. And we know this is called ethylene glycol. Ethylene means CH2CH2. So it is ethylene glycol. We have 2 OH group. We have 3 OH group, trihydric alcohol, and this is called glycerol. If it is greater than 3 OH group, then it is called polyhydric alcohol. So based on number of OH group present in a molecule, we are classifying as monohydric alcohol, dihydric alcohol, and trihydric alcohol. Then we have polyhydric alcohol. So monohydric, dihydric, and trihydric alcohol. Example, ethyl alcohol, then ethylene glycol, then glycerol. Polyhydric alcohol, if it contains more than 3 OH group. So as per syllabus, we have to discuss on monohydric alcohol. Monohydric alcohols again classified into different categories. It is based on the OH group attached to the sp3 hybridized carbon or to the sp2 hybridized carbon. So in classification, first we are classifying the alcohols into monohydric, dihydric, trihydric, and polyhydric alcohol. Again, in monohydric alcohol, we have different types of monohydric alcohol. Let us discuss the type of monohydric alcohols. So it is mainly based on to which carbon the OH group is attached. Okay, so here we are classifying monohydric alcohols into 2 categories. Compound containing OH group attached to compound containing OH group attached to or linked to sp3 hybridized carbon. sp3 hybridized carbon. So here again there are many types. One is saturated aliphatic saturated alcohols. Saturated alcohol. This is one type. The second type is allylic alcohol. And third type, it is benzylic alcohol. So monohydric alcohols are classified into 2 categories. One is compound containing OH group attached to sp3 hybridized carbon. Here we have 3 types. One is saturated alcohol, aliphatic saturated alcohol. Another is allylic alcohol. One more is benzylic alcohol. Now, what are these? Aliphatic saturated alcohol. So we know aliphatic compound. Aliphatic compound means non-cyclic compound. They are not cyclic. Example, as we know aliphatic hydrocarbon CH4, CH3, 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 CH2, CH3 and so on. So, aliphatic, saturated alcohol, all these are saturated aliphatic compounds, aliphatic hydrocarbons. I am replacing one nitrogen by the OH. As we know, it is a saturated. When the valency of carbon is completely satisfied, that is, if it is attached to 4 different or 4 identical or maybe different group, then we may say CH3. This is sp3. So this is sp3. Carbon is sp3. To this carbon we have OH. So it is OH attached to the sp3 hybridized carbon. Like that, here there is no double bond. When there is no double bond means it is, when there is a single bond, then it is nothing but sp3 hybridized carbon. So it is sp3. Ethyl alcohol. Here it is sp3. I am replacing one nitrogen of alkane or saturated aliphatic hydrocarbons by OH. You can write one more example, CH3, CH2, CH3. This hydrogen is replaced by one nitrogen is replaced by OH. This is also sp3. So what you have to remember is, when there is single bond between the carbon or when the carbon is attached to other groups or other atoms by a single bond, then it is sp3. So it is sp3 carbon. This is sp3 carbon because we have single bond. This is sp3 carbon, single bond. This is sp3 carbon. So it is aliphatic saturated alcohols. Now, we are classifying aliphatic saturated alcohols into primary, that is 1 degree alcohol, secondary 2 degree alcohol, tertiary 3 degree alcohol. So primary, as we are studied even in the halo alkanes, this is called primary 1 degree. Okay, so the CH2 or primary carbon is attached to the OH. So that is 1 degree alcohol. I think you are followed what is meant by primary. So what you have to remember? You have to remember CH2. It is primary. So it may be either, here I am writing R CH2 OH. R may be, it may be hydrogen or it may be some other group or alkyl group. So this is 1 degree alcohol. It is also called primary alcohol. Primary alcohol. Then 2 degree alcohol. 2 degree alcohol means the OH attached to CH. OH attached to CH is called 2 degree alcohol. Okay, it is 2 degree alcohol or secondary alcohol. OH, what you have to remember? OH attached to CH. So this is called 2 degree. Then we have 3 degree alcohol. In 3 degree alcohol, there is no hydrogen present on the carbon which is attached to the OH. So this is 3 degree alcohol. 3 degree. Now I am repeating again. 1 degree alcohol means the OH attached to CH2. 2 degree alcohol means OH attached to CH. 3 degree alcohol means OH attached to the carbon which do not contain any hydrogen. I am writing example here. CH3OH. It's a primary alcohol. We know it's called methyl alcohol. CH3OH. Then CH3, CH2OH. It is called ethyl alcohol. How to name this one we can discuss later in the nomenclature. At the time of discussion of nomenclature, this is called alcohol. CH4, CH3, methyl. OH is alcohol. C2H5 or CH3CH2. It is called ethyl. We know C2H5 or CH2CH3 is called ethyl. OH means alcohol. In this case, the OH is attached to the primary carbon or CH2 or CH3. Okay, one more example. CH3CH2, CH2, CH2, OH. So, butyl alcohol is called N-butyl alcohol. OH attached to the CH2. Then, what about secondary alcohols? CH is linked to OH. That is, OH attached to the carbon which contains only one nitrogen. Remaining two are some other group like alkyl or alkyl, etc. So, I am writing example for this one. CH3, CH, CH3, OH. So, see here we have two CH3 group. I am writing one more if you want. CH2, CH3. So, because both are identical, that means CH3, CH2, one group, it is a R. You may write this one as R dash. These two groups are different. It is secondary alcohol. Which secondary alcohol it is called? So, total number of carbon atoms 1, 2, 3, 4. 4 carbon are there. It is called butyl. For 4 carbon, we know butane, butyl alcohol. This is butyl alcohol. This is also butyl alcohol. See the number of carbon 1, 2, 3, 4. It's a butyl alcohol. But the difference is here OH is attached to CH2. That means 1 degree butyl alcohol. Or it's also called N, that is normal butyl alcohol. 1 degree is also called normal. So here there is a difference between the structure of these two. Both are butyl alcohol, but difference in the structure. OH group is attached to different carbon. So this is secondary. Why it is secondary? Because OH is attached to CH2. Secondary butyl alcohol. Secondary butyl alcohol. So secondary, now tertiary. In tertiary alcohol, the OH is attached to the carbon which do not contain any hydrogen atom. So I am writing example for this one is CH3, 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 OH. This is also butyl alcohol. See, total number of carbon 1, 2, 3, 4. 4 carbon are there. When we have 4 carbon, butane. So one hydrogen less means butyl. So this one is also butyl alcohol, but structure is different. Butyl alcohol. So here the OH attached to the carbon which do not attach to hydrogen. It is attached to carbon, not to the hydrogen, or it is attached to some other group. So this is called tertiary. T-E-R-T. Short you are writing tertiary. So I think you are followed in case of aliphatic saturated alcohols. Primary or 1 degree, secondary or 2 degree, then 3 degree or tertiary. How to identify? To identify primary, let us see the OH group or functional group attached to which type of carbon. This is called primary carbon or CH2. Secondary, OH attached to the CH or functional group attached to CH. So it's a secondary or 2 degree alcohol. Then tertiary, OH attached to the carbon which is not linked to the hydrogen, it is linked to some other group. It's called 3 degree alcohol. So it is about aliphatic saturated alcohols. Then second, it is analytic alcohol. Analytic alcohol. As we know, this is called analytic. CH2 double bond, CH, then this C. H2 or some other group, this is called analytic. So, example for analytic alcohol is CH2 double bond, CH2, OH. Okay, analytic group means the functional group attached to the carbon, okay, that carbon linked to the CH2 double bond CH. So this is called analytic. Functional group attached carbon or functional group containing carbon attached to the double bonded carbon or CH double bond CH2 is called analytic alcohol. So this is analytic alcohol. Then it is benzylic alcohol. Benzylic alcohol. So benzylic alcohol, the functional group attached to the carbon next to the benzene ring. Next to the benzene ring. So this is benzylic alcohol. Here it may be attached to the 2 hydrogen atom. So benzene ring, CH2, OH. And again it is not necessary that these two must be hydrogen, as we are studied in case of haloalkanes and haloarenes. It is not necessary. It must be CH2. It may be some other example. It may be R, it may be R dash like this. Okay, so we can also write benzylic as CH2 OH, or we can write some other group like CH, then R means it may be CH3 or some other group OH. It's also benzylic. Or here both the hydrogen may be replaced by some other group like it's a C2H5 or CH3CH3. Here CH3CH3 or C2H5CH3 OH. So these three are benzylic alcohol. So see, in case of a compound containing OH group attached to sp3, we have aliphatic saturated alcohols, then allylic alcohols, then benzylic alcohol. You see, in all these cases, OH group is attached to the carbon which is saturated or its valence is satisfied. OH group is attached to sp3 carbon, single bonded. OH is attached to sp3 carbon, single bonded. sp3 carbon, single bonded. sp3 carbon. What you have to see? OH. Where it is attached, that you have to see. OH attached to single bonded carbon. All these are single bonded. OH attached to single bonded. OH attached to single bond. So single bond means sp3. And here also, even in primary, secondary and tertiary, you can see the OH is attached to sp3 carbon. This is sp3, single bonded. This is sp3, single bonded. This is sp3, single bonded. You can see the examples. CH3, no double bond. Here there is no double bond. OH attached to single bond. Here there is no double bond. So all these are the monohydric alcohols, the compound containing OH group attached to sp3 hybridized carbon. Okay. So afterwards, in second type, compound containing OH group attached to sp2 hybridized carbon. So these compounds are called, it's a vinylic compound. So compound containing OH group attached to sp2 hybridized carbon, they are called vinylic compound or vinylic alcohol. So now simple example for vinylic compound is, as you are studied in the haloalkanes, it's CH2 double bond CHCl called vinyl chloride. Like that, vinylic alcohol means you can substitute the Cl by OH. So it is vinylic alcohol. It may undergo rearrangement. So we don't have a discussion on this compound containing OH group attached to the sp2 hybridized carbon, because it undergoes sometimes rearrangement and convert into the aldehyde. That's called, okay, some isomerisms here. It may undergo change. The hydrogen may pass to this one and it may change to CH3, CH double bond 2. So it may change to aldehyde. So we don't have a discussion on the vinylic alcohol. In vinylic alcohol, just to see here, the OH is attached to which carbon? Double bonded carbon. When we have double bond, it is called sp2 hybridized. So carbon is sp2 hybridized. In first case, we have studied the compound containing OH group attached to the sp3. There we have many categories. There we have saturated alcohols. There we have studied analytical alcohols. There we have studied benzylic alcohols. So here only one example, that is OH attached to the double bonded carbon. So there may be some question arise in mind that, so here in case of benzene, all carbon are sp2 hybridized and each carbon contains each carbon contains one nitrogen atom. Instead of tinkering, I am writing the alternate double bond. So all are sp2 hybridized. If you substitute hydrogen by OH, then this compound become the hydroxy compound, but it is not alcohol. Remember this point. This is another class of compound called phenol, aromatic hydroxy compound it is called. So we have discussed this in this topic only after the alcohols. I think all of you followed about the classification of alcohols. Now let us discuss on the nomenclature of alcohols, that is naming the alcohols. As we know, we are naming any organic compound by two methods. One is it is a common name and another is IUPAC name. So IUPAC name is more important compared to common name. For the competitive examination or even for the annual examination, you have a question based on IUPAC nomenclature, write the IUPAC name of the compound like that. So in the IUPAC nomenclature and in common name, first we should know how to name the organic compound by common method. I am writing example here. Nomenclature of alcohols. So we know organic compounds are named by two methods. One is by trivial or common name and another is by IUPAC name. Even in the haloalkanes we are studied how to name the haloalkanes by common system and by IUPAC system. Now in common system, I am writing for saturated this alcohols. In common system, the compounds are called alkyl alcohol. Alkyl alcohol. The alkyl may be normal, that is a primary. Alcohol may be iso. Alcohol may be secondary. Alcohol may be tertiary. Alcohol may be neo. That is the common system. In common, it's a primary, iso, secondary, tertiary and neo. So, primary example, this is primary CH3, CH2, CH2, OH. It's a 1 degree or primary. As we know, primary means OH attached to the CH2, 1 degree. Then this is called iso. Remember, this is very important. There is a difference between the iso and secondary. This is called iso. CH linked to 2CH3 group is called iso. So it's a iso propyl alcohol. Means you have to identify primary, secondary, tertiary or neo. In secondary, CH3, CHOH, CH2, CH3. Here the CH is not attached to 2CH3. Identification is very important. When CH is not attached to 2CH3, but it's attached to OH or some other group, then it is called secondary. See the difference. Here CH to 2CH3, here CH not to 2CH3, we have 1CH3 and some other group. Okay, this is called secondary. Number of carbon 1, 2, 3, 4. Secondary butyl. 4 means butyl alcohol. Then tertiary. For tertiary, we have the OH attached to the carbon which do not contain any hydrogen atom. So this is tertiary because this carbon do not attach to hydrogen, it is attached to the 3 CH3 or 3 some other group. So it is tertiary. Now to name by common system, see the total number of carbon 1, 2, 3, 4, 4 carbon we have. For 4 carbon it is called butyl. So tertiary butyl alcohol. I think you are followed how to identify primary, secondary and tertiary. Then what is this neo? Neo alcohols. Neo means this is called neo. You are studied in QC first year. Neopentane, isopentane and normal pentane. This is called neo. This one is called neo. So neo alcohol is called. Which neo it is? How many carbon we have? 1, 2, 3, 4, 5. 5 carbon we have. So it is neopentyl alcohol. This is about common system of naming the alcohols. In general, alkyl alcohol, saturated I am using alkyl alcohol. So it is 1 degree or N. It is also called N or normal propyl alcohol. This is called iso because CH attached to propyl alcohol. Totally we have how many carbons? 3 carbon, isopropyl alcohol. This is secondary, CH attached to the OH, but CH is not again linked to 2CH3, so it is secondary. Total 4 carbon butyl. Here we have total 5 carbon, so it is a neopentyl. This is called tertiary. This carbon do not contain any hydrogen atom. So this is common system. Now about IUPAC nomenclature. In IUPAC system, we know the suffix for alcohol. IUPAC system of naming the compound. Suffix for alcohol. Suffix is very important in the IUPAC. Suffix as well as prefix, both are important. Suffix means functional group. OH is the functional group and suffix for alcohol is or, ON or. So suffix for alcohol is ON. So it is alkanol, methanol, ethanol, propanol, etc. But remember, in IUPAC system, numbering is important. As you are studied in QC first year, you have to number the carbon from the end which is close to the functional group or OH group. From that end you have to number. So I am giving some example here. This is the simple example, CH3OH. Suffix is ON. In IUPAC system, alkanol. E is replaced by, this E is replaced by ON, alkanol. So many carbon? 1 carbon. 1 carbon hydrocarbon is methane. So it is methanol. E is replaced by ON, methanol. Then this one CH3, CH2, CH2OH. Its common name is normal propyl alcohol. IUPAC name is total number of carbon atoms are 3. So it's a propane. Can you write the name of this one as propanol? No. We cannot write the name of this compound as propanol because we have a OH group on first carbon. Here the numbering of the carbon do not arise because we have only 1 carbon atom. But whenever we have 3 or more carbon atom, then you must number the carbon from the end nearer to the functional group. So here it's a carbon number 1, 2, 3. So it is propan 1R. Propan 1R. What about this one? CH3, CHOH, CH3. As we know, the common name is it's isopropyl alcohol. IUPAC name, you may number from this end or this end. Because when if you number from both ends, the carbon which is attached to the functional group carry the number 2. So it is 1, 2, 3. Or it may be 1, 2, 3. So usually it is a simple pro and 2O. On the second carbon we have OH. Similarly, this one CH3, CH2, CHOH, then CH3. From which end you have to number? From this end. Because 1, 2. Suppose it is numbered from this end, then the functional group or OH carrying carbon is 2. If you number from this here 1, 2, 3, then it is on third carbon, it is par. So the name of this one is 1, 2, 3, 4. It is a propan 2O. So I want to give some examples again for naming the alcohols by common and by IUPAC system. Okay, so I am writing the structure or formula on the first column. It's a formula or you may say structure. Second column, common name. And third column, IUPAC name. IUPAC name. So formula CH3OH, then it is CH3, CH2OH. I am writing some example here. CH3, CH2, CH2OH, CH3, then the CHOH. Suddenly, if you want to write the OH along the CH, then you must put that in a bracket in order to avoid the confusion. CH3, then the CH3, CH2, CHOH, then the CH3. Afterwards, it's a CH3, CCH3, CH3OH. Then we have CH3, 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 CH2OH. Then we have, again you can write few more examples. It's a CH2, double bond CH, CH2OH. Then we can write this also. It's C6H5, sorry, C6H7OH. We can write this one like this. So CH3. Then we have OH. So common name alkyl alcohol. Common is alkyl alcohol. IUPAC name alkanol. IUPAC name is alkanol. So common name methyl, ethyl, propyl, then propyls, then it's a butyl, neo, then vinyl. We don't have common name for this. Now it's a one carbon, so we can write it as a methyl alcohol, common. This one is ethyl alcohol. Next one, propyl alcohol. As we know, identification is important. In common, identification of carbon, what type of carbon it is important. So here CH2 attached to the primary carbon, that is CH2. So it is OH attached to the CH2, that is primary carbon, and it is called N-propyl alcohol. OH is linked to the CH, so it is called iso. CH means it is attached to 2CH3, as you have studied. Isopropyl alcohol. Isopropyl alcohol. This one is called secondary. It is not iso. It is called secondary. As I told, identification is very important. It's a secondary butyl alcohol. Secondary butyl alcohol. And this one is called tertiary. Tertiary butyl alcohol. This one neo. This is neo. This group is neo. Neo, total number of carbon atoms are 5. So it's neopentyl alcohol. And we know this is called allylic. So it is called allyl alcohol. This one is called, cyclohexane. We don't have a common name for this one. For this one also we don't have a common name. Now IUPAC nomenclature. See, according to IUPAC, the alcohols are called alkanol. Alkane, 1 carbon methane, 2 carbon ethane, then propane, butane, etc. It depends on how many carbon atoms are present. And when we have 3 or more carbon, writing the number is very important. Numbering the carbon is important. Number the carbon from the end which is close to the functional group. So 1 carbon, no need of numbering, that question does not arise. So it's a methanol. Methanol. 2 carbon. Question now, numbering of the question does not arise because only one functional group is there and 2 carbon. So there is no other possibilities. It is the ethanol. For writing the structure, there is no other possibilities. Now 3 carbon, numbering is needed from the end close to the carbon. 1, 2, 3. So this one is propan 1-ol. Then this is propan 2-ol. 1, 2, 3. So it is propan 2-ol. On the second carbon we have OH or functional group. So it is propan 2-ol. This one is totally 4 carbon. Butane. On the second carbon we have OH. So it is butane 2-ol. Okay. Then this one is tertiary butyl alcohol according to common. Now number is important from the end close to the functional group. You may number from this end 1, 2, okay, or you may number from here 1, 2, 3. Which method is correct now? 1, 2, 3. 1, 2, 3. Both are correct because you have to select the longest chain. The longest chain contains only 3 carbon. 1, 2, 3. Continuous chain must be 1, 2, 3. I am numbering from here 1, 2, 3. You may number from this end also. If it is numbered from this end 1, 2, 3 or 1, 2, 3, the functional group carry the second carbon only. On the second carbon only we have functional group. It may be from this end or from any end. So the name of this compound is total number of carbon atom in the long chain containing the functional group are 3. So it is a derivative of propan 2-ol it become, but we have one more group CH3. You are not counted that one and we know that is called substituent and it is on the second carbon. So name of this compound is, first you have to name the substituent, it is called prefix. As you studied in the PC first year, it is called prefix. The prefix is CH3. CH3 is called methyl. Methyl. 1 hydrogen less compared to methane. 2 methyl. On the second carbon methyl, total number of carbon atoms are 3 in the long chain. Alkanol means it's a propanol. On the second carbon, again we have OH. So it is 2 methyl propanol, propan 2-ol. This one, numbering is important. 1, 2, 3, no, because it do not include the functional group. You have to select the long chain, a continuous long chain. That chain must include the functional group. Here if you number like this, 1, 2, 3, there is no functional group on these 3 carbon. So the numbering must be like this. It must include the functional group OH. 1, 2, 3. So it is 1, 2, 3. I think you are followed. Why is not numbered like this? Because no functional group or OH group on this carbon. So here on this carbon we have functional group. So you must number like this 1, 2, 3. Again it should not be like this 1, 2, 3 because then the third carbon contain OH group means functional group is present on the third carbon. That is the wrong method according to IPC system. It must be close to the functional group. So this is the correct one. Now the name of this compound is 2-methyl. 2-methyl. 2, sorry. We have 2 carbon atoms. These are the substituents. Now these are the substituents. So it is 2 identical substituents are there. The locants are respective to the 2, 2. Number of identical substituent are 2. So it's a di, methyl. Then it is 2, 2 dimethyl propan 1-ol. the IUPAC name of this compound. Well, next one is again interesting because we have two functional group here. Even double bond is also considered as a functional group. We have two functional group. One is a double bond and another is OH. The question arises, from which end you have number the carbon, whether from the carbon having a double bond or carbon attached to OH. According to priority order, OH comes first, then the double bonded carbon, which is at the end double bonded. So, according to priority order, it must be OH. That means your number from this carbon 1, 2, 3. So, first, second, and third. Now, the name of this compound is total number of carbon atom. This hydrocarbon, there is no substituent. So, in this case, we have substituent. You are named the prefix. Substituent is a prefix. No substituent here. It's a long chain. So, see the number of carbon atoms 3. It's a prop. Afterwards, we have a double bond, that's En. We know double bond is En. Triple bond is called Yn. Okay, so it is 1, 2, 3. Prop. Total number of carbon atoms are 3. Prop. On the second carbon we have En. Second and third carbon. That means it is a 2. Prop 2 En. It is not prop 2 En. It is not a prop 2 En or propene. This is because here it is not ended. We have functional group again. So it is a prop En. Okay. Then On. Okay. So it is a 1 On. Even no need to write 1 On. Simply you can write prop 2 enol.